Okay, guys, I'm going to stop you where you're at. Hopefully I can explain today's stuff better than I did first hour, because first hour was a complete disaster. I actually pondered becoming a mechanic for about 30 seconds because it was going so bad, but I think I'm going to stick with teaching because I've already got 14 years. So it wasn't bad because the students were bad. It was bad because I just kept messing up, and I was making the silliest, like, tiny mistakes. There's only like 5 questions today, and I messed up on 3 of them. So I was feeling horrible. But I've regrouped. I'm back mentally, and I'm ready to dominate again. So we've learned 5 factoring methods: the ABCs, what's it called, the grouping, and then the squares and cubes. Which method is this one? It's supposed to be grouping, because right away you see that has 4 things. So the way that grouping works, since there's no GCF, we can immediately split the middle with parentheses. Did any of you recognize that there was a minus in the middle? Yeah. Because you have to make an adjustment when there is. The adjustment comes in the second set of parentheses right in the middle. The sign has to change. So now we can do our GCF work. The GCF of the first one is x squared. When I take out the x squared, I'm left with x plus 2. Then I bring down the minus. The GCF to the second one is 4. And when I take out the 4, I'm left with x plus 2 again. So by definition, if they both have it, it's a GCF. So they both have the blue x plus 2's. So I pull it out to the front. And then I create a second set of parentheses with those original GCFs, x squared minus 4. Now as I walked around, I noticed that some of you stopped there and then solved, which is fine. But I'm afraid that if you do that, you're not going to get the third answer. It's supposed to be 3 answers because this is x to the 3rd power. So hopefully you guys start to recognize that if there's still an exponent, that might be some of our special ones that only have 2 terms, which in this one, it works out to be a difference of squares. A difference of squares is going to turn into 2 more. One's going to say x plus 2, and the other one's going to say x minus 2. Then we bring down the x plus 2, and now we bring back the 0 because we're done factoring. So factoring means rewrite it using the parentheses. Solve means tell me what x needs to be. So if I set x plus 2 equal to 0 and subtract the 2, I get negative 2. If I take, it's going to be the same thing. It's the same problem. So negative 2. And then right here, this one's going to give me positive 2. So the part where people were messing up was on this part right here. They were going like this and solving it, which is fine. There's nothing wrong with that. You're just forgetting one thing once you do this step. Anytime you square root, you actually get 2 answers out of it. You get a plus and a minus 2. So that's the part that people were missing. So when I was walking around saying, how many answers are you supposed to have? Some of you told me 2, and it was supposed to be 3. You were missing it because you didn't put this right here. So if you just factor it completely, usually that alleviates that problem. Okay, so these last 2 days have been division, right? The first day we spent, it was Friday, we spent all class practicing long division. And then yesterday we practiced the shortcut, the synthetic division. Synthetic division only works sometimes, but we can actually use it to our advantage when certain problems don't factor. Now there are 2 things I need to teach you today. And really, to me, they sound like the same exact thing. So, you guys remember what a remainder is? What is a remainder? Yeah, so like after you're done dividing, if you have something left over, that's a remainder. Now here's the catch. What I'm about to teach you right now is called the Remainder Theorem. The Remainder Theorem is the shortcut to figure out if there's going to be a remainder and what that remainder is going to be. So what I'm telling you right now is if you want to know the remainder, you actually don't have to divide. So here's what we do instead. It says right here, when we divide a polynomial, f of x by, so this is the stuff that we're dividing by. So when we go like this is x minus c. Now, this problem, I got a question for you guys. Could I do synthetic division on this question? Yeah, because we learned yesterday that if you have a 1x here, you can do synthetic division. So if I was to convert this to synthetic division, what's the thing that goes right here? But not the x. We never put x right here. Yeah, in this one it would be plus c. Because the rule is, whatever this number is, when we put it into synthetic division, the sign changes, right? The reason I'm explaining that is because that's what the remainder theorem makes you do. The remainder theorem makes you plug in the opposite sign. So this right here is the opposite. So in the other class that just left, they were a little confused because whatever the problem told them, they just automatically put the opposite. Guys, you only put the opposite if you have the x. If they tell you plug this in, just plug that in. Don't change that sign. Now hopefully you guys have a calculator handy. Do you guys have your calculators with you? Okay, turn them on because pretty much the first page is all calculator work. So here's what they want us to do. They want us to test f of 3. So they want us to do f of 3. So before you guys start typing, hold on a second, look up here. F of 3 means we're really checking to see if x minus 3 can go into that other problem over there. So we're going to plug in 3. So this is 3 to the third minus 5 times 3 squared plus 3 times 3 plus 20. Oh, just kidding. Not 27, just 7. Plus 7. So in the calculator, you're going to enter in exactly that question. Did you get 28? 28? 28? I was just waiting. Hopefully someone, I thought I heard someone say 28. Say 28? Anyone? 28? Going once? Is anyone typing this? Help me out. I don't have a calculator up here. Oh yeah, that's the second guess. The answer is -2. So let me explain to you what this means. When you do that, that's the remainder. That's why this is called the remainder theorem. It says that if you just plug in the number, whatever it spits out is going to be the remainder. And I can prove it to you. I can prove it to you using synthetic division. Now, this part is just the proof. You don't have to do this on your assignment. You don't have to do this on the rest of the notes. I'm just going to prove it to you. So using synthetic division, this would be 1. This would be -5. This would be 3. And this would be 7. So I'm just using the front numbers. And then I'm testing the 3. So I go like this. The first one comes straight down. We multiply. That gives me 3. Then we add. That gives me -2. Then we multiply. That gives me -6. Right? Am I good so far? And this gives me -3. And then I multiply. And that gives me -9. 7 take away 9. Bam! So guys, what we just saw right here is exactly what you end up right here. So I'm telling you, you don't actually have to divide if they ask you what the remainder is going to be. All you have to do is plug in the number and it'll tell you. Does that make sense so far? Okay, so do it for the second one. Since you guys have calculators, I'm going to write what you should type, and then I need someone's help to see what the number is going to be. So we're putting all this stuff in. This time they want us to test -2. Final answer? Okay, I got 2 different answers. +6? Are you guys typing this? You have all the exponents. Anyone get 3.14 yet? Are you guys messing with me because it's Halloween? Okay, hold on, I'm going to double check. So we're plugging in -2. Negative 2 times 2 to the third. 3 times negative 2 squared. Negative 3 times negative 2 plus 4. It's 6. It's 6. I don't care what anyone else says. It's 6. So that means it's the remainder. So let me ask you guys this question. When we tested negative 2, what were we really checking? We're trying to see if something divides, right? Well, if we're testing negative 2, what's the problem? We're trying to see that if it divides or not. And you have no idea because that's the worst question I've ever asked in the history of teaching. I'm trying to get you to say something without actually telling you what it is. Take a look at the last question. The last question, we plugged in 3, but we're not really testing the 3. We're testing what's above it, right? We're checking to see if x minus 3 is going to divide. So in the second problem, what is it I'm really checking? I'm trying to see if x plus 2. Perfect. So the catch here is when you test that number, it's actually the opposite with the x. So we're trying to see if x plus 2 divides evenly into that other problem. Now there's a reason why I'm trying to get you to say that, because in the next question, you have to actually say this. It says state if the given binomial is a factor. So when you're done with this, you either say yes, it's a factor, or no, it's a factor, or no, it's not a factor. So we're going to check this again. So notice this problem looks a little different. So what am I going to plug in? Yeah, so I need to plug in positive 2 into that problem up there. So I end up with this. Something to the third minus something squared minus something minus 2. And I'm plugging in the positive 2. Positive 2, positive 2. So we're typing this in. And we get 0. So wait a second. I told you earlier that when you have a number to plug in, the leftover number is supposed to be the remainder. What does it mean when you have a remainder of 0? It means that it divided evenly. So the way that we say that is this thing right here. We say that x minus 2 is a factor. Hey guys, you'd be surprised. Last year's class would leave this question blank. It says state if it's a factor. All you have to do is plug in the opposite number, see what number it gives you. If it gives you anything besides a 0, you would say it's not a factor. If it gives you a 0, then you would say it is a factor. So let's try it one more time. So in the second one, what do I need to test? What am I plugging in? 7. So this time it has to be a positive 7. So something to the fourth minus 8 to the third minus parentheses plus 62 parentheses minus 34. We're going to test 7. 7, 7, 7, 7. What'd you get? That's it? Just 8? Good. Oh, I screwed up. Hold on. I missed an exponent. This should have 2. There. I got 8. 8? Yeah. Did you miss the 2? That's my bad. I'm going to say it's, I heard more 8s, so we're going to say it's 8. So this is our remainder. So is x minus 7 a factor? No, because it doesn't work. The only way it works is if it gives you 0. So it's not a factor. So when it comes to the test, you guys just got to remember what this means when it says this right here. Tell me if it's a factor. It means plug it in. If the number is 0, yes, it's a factor. If the number is not 0, then no, it is not a factor. So I told you that I was going to teach you two things today, right? That was the first one. It's called the Remainder Theorem. Now, it's so dumb, but the thing that I have to show you is pretty much the same, and it's on the next page, but this one is actually called the Factor Theorem. And the Factor Theorem is the same exact test as the one that we just did. So if it says x minus c, we're going to plug in positive c. So no matter what it is, we always change the sign when we plug it in. The only difference is it's called the Factor Theorem when it does give you a 0. And you saw that on the last page, the first example we did. When we got 0, we said it is a factor. So I don't understand why they had to come up with two different names for it. I guess it's just special because a remainder of 0 means it works, therefore it is a factor. So what I'm going to tell you is we are going to use this in factoring. So you guys remember these 5 things? Simple ABC, complex ABC, grouping, difference of squares, sum and difference of cubes. This fact right here actually helps us change problems that cannot be factored. So here's what I want to show you. First of all, remember how I said in first hour it was a complete disaster? 3 out of the 5 problems I got wrong. This one was the worst one ever, and I figured out after we were done that it actually just doesn't work. So I'm going to show you on problem 2 what we're supposed to do with it. So take a look at this problem. Actually, everyone put your pencils down. Put your pencils down and just help me out up here. So take a look at this problem. The directions say to factor completely. Factor means rewrite it so it has parentheses. So based on how it looks now, what method is best for that type of question? Grouping. Okay. So check this out. And don't write this down, please. So do you guys remember what happens when there's a minus in the middle? Changes the signs. Okay. So what's the GCF of the first one? 6x squared. And then we're going to be left with? Okay. So then over here, GCF of the second one? What's so 6? Yeah. Okay. So what are we left with? Do you guys see the issue right now? Yeah. What's the problem? When we do grouping, the parentheses are supposed to match, right? So it's not working right now.
Oh, we can take out 6 from the beginning.
Yeah, but it's still not going to work because that's not going to affect this and this. You'll end up with the same 2 parentheses anyways. So what I'm telling you is factoring by grouping right now does not work. But they give us a fact at the very beginning. This is where you need to pick up your pencil and take some notes. Check out this fact right here. They're telling us when they plug in 5 to that problem, it gives you 0. So here's what that means. This right here means that x minus 5 is a factor. Right? That's what we saw on the last page. If it gives you 0, it means that it's a factor. So if it's a factor, shouldn't we be able to divide it out?
Yes.
It's going to divide out evenly because that's what it means to be a factor. So here's what we're going to do. Our problem doesn't work as is. So what we're going to do is we're going to divide out the x minus 5. And we're going to change the problem into something else. Now, some of you said yesterday you prefer long division. I don't like long division. I'm going to do synthetic on this one. So I'm going to try this 5, and I'm going to do my synthetic stuff. So synthetic uses the front number of all of the letters. So we're using the coefficients. 6, negative 24, negative 42, and 60. Should I have any zeros in this? So when you check that, you're looking at exponents. All of the exponents have a spot. X to the third, x squared, and then x. So we're good. What was the very first step of synthetic? Yeah, this one's no work. That one just goes straight down. So we put the 6 here. And then 6 times 5. And then we combine those. And then 6 times 5, 30 again. We combine those. Negative 12. And then we multiply. That's negative 60.
Oh, yeah.
And in the end, we get the 0. We knew that was going to happen because that's what they told us right here. So now check this out. We're going to rewrite the problem as this. This was x to the third, so I take 1 off of that, and this becomes 6x squared plus 6x minus 12. Now can we factor it?
Yeah.
So first of all, yeah, there's a 6 you can take out. If you take out the 6, this is x squared plus 1x minus 2. That's a simple ABC. So we make the list for negative 2. That's the whole list. We're trying to make 1, and it needs to be a positive 1. So it's negative 1 and plus 2. So this answer is going to say x minus 1 and x plus 2. Now, this is actually wrong right now. Remember how it says factor completely? When we're done factoring, we should be able to FOIL it and get back to the original problem. What we have right here, is that going to give us an x to the third?
No.
So where's the third x? Where's the third x in blue? Yeah, it's up here. It's in blue. It's x minus 5. They told us from the start. They told us from the start that was one of the factors. So now this is how you factor completely when it doesn't work. So we use one of the factors to lower the exponents and change the problem into something else. Once we do that, that should factor. Once we factor, we have to just remember to put this back into the answer. Because the original problem says x to the third, so that means we should have 3 x's when we're done. I'm going to do that one more time because I see some looks on your faces and I'm not convinced that you're confident about this. So let's talk about what this means again. What does that mean? What's a factor? It's actually x plus 2 is a factor. So guys, what that means is when we're done, we need to attach the x plus 2. So we use this as a benefit because this problem, I promise you, it's a complex ABC, but it doesn't work. There is nothing in 16 that can make 6. So that's why we need to divide to change the problem into something that will work. So the way we do that is through synthetic division. So I use negative 2. Let's see. 2, 6, 0, negative 8. How come I put a 0? Yeah, there's a missing x. It goes x to the third, x squared, and then it skips to 8. So the x is missing. So I put a 0 in that spot. So we go like this. That multiplies and gives me negative 4. So that becomes 2. We multiply again. That's negative 4. So that's negative 4 again. We multiply, and that gives me plus 8. So we knew this was going to happen because they told us it was going to in that fact on the side. So now this is the new problem. Take 1 off the highest exponent. So this is 2x squared plus 2x minus 4. Now can that be factored? I think so. I see a 2, and a 4 though. There's a GCF on that one. You could take out a 2. So we're going to rewrite this. X squared plus 1x minus 2. Hey, isn't that the same as the other problem? I already have this answer for this one. It was x, what was it? I forgot. Minus 1? Minus 1 and x plus 2. And then we have this 2 in the front. And the problem was supposed to say 3 x's. So we just take this one right here and put it back. So that's the problem completely factored. So when these when these 5 factoring methods don't work, when simple ABC doesn't work, complex ABC, grouping, difference of squares, sum of cubes, when it doesn't work, you have to use this fact right here to make it work. So what that does is it lowers the exponent, and then one of our methods will work after that. Just don't forget to put this guy back. That's the most common mistake on this stuff. You're changing the problem so it will factor. You just have to make sure that all 3 factors are there. So you guys have about 30 minutes, maybe 20 minutes to practice this. The assignment goes all the way to 16 and it goes across 3 pages. So make sure you do them all. And the answer key is already done-ish, I think. So I'll post it on the wall here in a few minutes.